Hey there, Nick Judithakis here. In this video, we're going to go over a practical example of building a 12-factor app. Now, if you've never heard about 12factor.net before, we are going to start by going over the introduction and the background and how it originated and stuff like that. But for now, I just wanted to give you the TLDR. Basically, Heroku, all the way back in 2011, created these very nice factors or guidelines or best practices on how to build a web application in a very flexible and resilient way. So basically a way for you to run this on one server or multiple servers and basically make it very easy to, release your application across multiple environments in basically a stateless way. So in this video, we're going to go through each one of these 12 different factors here and go over some source code of a specific application here, this example Flask app that I have that's open source, and we will see how they apply back to a real application. Now, the beauty of this whole 12-factor setup here is it will apply to any language or web framework or tech stack. So, if you happen to not be using Flask or Python and you'd rather use Rails or something else, that's no problem. All of these things apply. It's actually very nice. So, but if you've never heard about it, again, let's just start with the introduction because it really sets the stage of what we're about to get into. And by the way, before we actually get into it, each one of these factors here, it's basically just a page or two of information. This video is not going to be like 8 hours long. I have no idea how long it's going to be, but we will see in the end because none of my videos, like, as you know, they're not really scripted or planned or whatever. We just roll with the things and see where we go. But let's start with the introduction here. And I'm not going to just narrate things word for word here. I'm going to do my best to try to just live summarize things as I go here. But, in the modern era here, software really is delivered basically as software as a service nowadays, right? And the 12-factor app is basically just a methodology or a strategy for building SaaS apps in a certain way that are adhere to all of these bullet points that we see here. So basically, have a clean contract with the underlying OS and offer maximum portability between execution environments. And this is pretty interesting stuff, kind of already, because here we are in 2022, but this guide was written in 2011, and things like Kubernetes or Docker, they weren't, they didn't even exist. But this idea of offering maximum portability between execution environments is a really important one, and it kind of transcends actual technologies that we have. Like, these are really, they are methodologies that just you can apply them to different technologies, even technologies that don't exist yet. So this idea of maximum portability, that's great, right? Like, we can run our application in such a way where, if we're running it on one server using Docker Compose, or we happen to be running it inside of a Kubernetes cluster, or you happen to be running it on Heroku or something like that, your application should be developed in such a way where, at the very best, maximum portability, like best case scenario, your app code really shouldn't need to change to be able to run in those different environments there. And it also says suitable for deployment on modern cloud platforms, stuff like that, and minimize divergence, right, between development and production. Like, this one is a really, really important one because, if you're developing your application on your dev box and you have your application running in production, you don't want to have any surprises in production, right? You would like to be able to catch everything in development, or maybe in a worst case scenario than development, like maybe in your CI server. But in development, you have things like folks running Mac OS, or maybe you're like me and you're using WSL2 on Windows, or maybe you're running native Linux. But what distro of Linux are you running? It's probably going to be, potentially will be different than what you're running in production. And you definitely want to minimize divergence between these. And it's interesting because back when this was written, Docker really didn't exist. Now, there were things like Linux containers and stuff like that, but today it's easier than ever, I think, to do this because if you're using Docker, there's very minimal divergence between these different environments because you can just build your Docker image and run it on your MacBook or WSL2 or whatever. And if you're running, let's just say on, one VPS or, a self-managed server on the cloud somewhere, the way it runs in production is basically the same, right? Because it's just running inside of a Docker container. And also they talk about continuous deployment here for maximum agility. I love how they just, throw around some buzzwords like this. But continuous deployment, also very nice end goal to have in mind. And then also, they talk about scaling up, right? Without significant changes to the tooling, the architecture, or development practices. And this is also a really interesting one because it would be nice to build your apps in a certain way. And let's just say that you want to start out by running it on a single server with Docker Compose, but maybe, after a couple of years, your application is building and it's growing, it's becoming really popular. And now it's like, whoa, it's time to actually start scaling out to multiple servers because we want some benefits that gives us. it would really suck if you had to like rewrite your entire application for that. So there's definitely a ton of best practices and stuff that you can do to write your apps like the right way from the beginning, so that scaling them out later is a lot easier. And yeah, it will be up to your discretion on how far you want to follow that, because usually this stuff comes down to complexity versus time and decisions like that. So yes, these 12 methodologies, they can be applied to any app, right? Written in any programming language. We covered that before. It doesn't really matter what tech stack that we're using. And yeah, let's talk a little bit about the background, right? So this was a document that was directly involved in the development and deployment of hundreds of apps. And yeah, I mean, back then it was 2011. So here we are in 2022. I don't know how many apps they have. They also talk about here too, like, scaling of hundreds of thousands of apps via our work on Heroku platform. So yeah, I mean, this is a proven model that just has been backed by actual like real life results here. It's not just them sitting down, like theory crafting a set of stuff. And yep, so this document synthesizes all those experience, basically, just summing all this stuff up. Best practices were extracted, and here we are. So yeah, let's talk a little bit about maybe who should read this document first, right? Like it applies to anyone building web applications as well as anyone who is potentially involved with deploying them as well. So, I kind of don't like to use the term like DevOps engineer or something, but like, if you are a developer, totally worth reading this for sure. If you're more on the operations side, absolutely worth reading that one. But yeah, let's just start rolling into this one, and we'll just start with the first one, which is the Codebase. So we can just click the link here and you can see, right? It's just basically just a page or so of just information here. But in terms of the code base, they just say one code base tracked in version control can handle many deploys. So what's really nice about this one, and keep in mind also for context, this was written back in 2011. Like some best practices now are just much more ingrained of like, of course you would keep your application version controlled, but maybe back then, not so much. But this first one, it's kind of like, it's a gimme, right? It's like setting us up for a pretty easy one nowadays. So, Git is my tool of choice here. If possible, I would like to host stuff on GitHub, but GitLab and Bitbucket are all totally fine alternatives. I'm sure there's other ones out there as well. But the idea here, right, is any single repo here should be version controlled. And if you have basically a couple of different services, then each one of them should be in their own independent Git repo. And then, yeah, they're all independently deployable. They're all independently developed, etc. And you can also deploy them into different environments here. If we take a look at this picture here, you have one code base that's being deployed to production, to staging, to maybe different development environments, like all stuff like that. And I think they're actually talking about like literally different developer environments in the sense that like, different developers working on the project, they go on to here to say that a developer's dev box is like technically a type of deployment. I mean, you're not deploying it in the sense that like customer facing traffic is going to hit it, but it is like, a way to run your application in an environment. And that's basically what all this stuff sums down to here, right? So they say there is always a one-to-one correlation between the code base and the app. So if there are multiple code bases, it's not an app, it's a distributed system. Like each component in the distributed system can each individually comply with the 12-factor methodology. So multiple apps sharing the same code is a violation of 12-factor. The solution here is to factor shared code into libraries, which can be included through a dependency manager. So if you're working with a Python app, you might want to throw some stuff up on PyPy or maybe a private repo on GitHub that you can pull down and have it managed through pip or whatever tool that you want, right? If you're using Ruby, there's always your gem file there. You can, version lock your stuff down and then gem install stuff. You get the drill, right? With a node ecosystem, you could be using NPM or Yarn, etc. It's not a good idea just to have multiple apps sharing the same code. Potentially, I don't know what they exactly mean by sharing the same code without making libraries. Maybe they mean like duplicating some stuff, or yeah, I don't know, maybe just sharing stuff on a file system potentially without using version control, which is probably what they mean. But they talk about here like one code base per app, but there will be many deploys of the app. So this is what they're talking about here, where you can have potentially production, a staging environment, QA environment, a test environment, whatever you want. But a deploy is a running instance of the app, typically production site, but could have other environments as well. But yeah, they talk about here, like every developer has a copy of the app running on their local dev box, and that qualifies as a deploy. So the code base is the same across all of these deploys, although different versions may be active in each deploy. For example, a developer has some commits they have not yet deployed to staging, but then staging might have some stuff that's not deployed to production, right? You have this pipeline of like, you have some code in dev, some in staging, and then some in prod. Technically the same code base, just different commits. But they all share their same code base, thus making them identifiable identifiable, or whatever they say here, as different deploys of the same app. So that's where we are there. So let's move on to the next one here when it comes to dependencies, or explicitly declare and isolate dependencies. And I'm finding that, this video may be longer than I thought. It may actually be faster for me to kind of just read this stuff and maybe interject some opinions or whatever along the way, rather than try to like summarize all of it and then like go back and read it anyways. So most programming languages offer a package system for distributing support libraries such as CPAN for Perl or RubyGems for Ruby. So libraries installed through a packaging system can be installed system-wide, known as site packages, or scoped into a directory containing the app, otherwise known as like vendoring or bundling. So if you've ever done something like an npm install and you just have like a node modules directory, that's what they're talking about over here. And a 12-factor app never relies on implicit existence of system-wide packages. And nowadays, this problem is way easier to solve with Docker, but they go on to say like it declares all dependencies completely and exactly via dependency declaration manifest. Furthermore, it uses a dependency isolation tool during execution to ensure that no implicit dependencies leak in from their surrounding system. The full and explicit dependency specification is applied uniformly to both production and development. So that's a lot of complicated words to basically just say, like, for example, you have bundler that offers a gem file for Ruby, Python, we have requirements.txt if you're using pip. But yeah, this is for declaring your dependencies, and you can also use bundle exec there for dependency isolation. And then they also say too, by the way, if you're a Python developer, you could be using virtual environments as well. But again, in today's world, if you happen to be using Docker, we get some very great isolation just from using Docker there, because every single application basically runs in its own isolated universe that includes system-wide packages too. And I think maybe they go on to talk about system-wide packages a little bit here, but let's ignore the stuff about C here because it's not important. You get the idea, right? Different languages have different tools to do this. Now, they also say here, like, one benefit of explicit dependency declaration is that it simplifies setup for new developers to get going. And that absolutely is totally true, right? Just having a gem file or requirements.txt file where you can run, a bundle install or a pip install and everything is all set up and good to go. Totally nice, instead of expecting a new developer to have to run, like 17 different commands to get something up and running, in case you didn't have this file here. And who knows, like if it wasn't version locked, they might get different versions and you get into all sorts of trouble here. So, but now they're saying, a new developer can just check out the code base into their dev box, require only the language's runtime and dependency manager as the only prereq, and that's it. And it's honestly even easier nowadays with Docker because you don't even need to worry about installing the language runtime. And you just git clone and literally run a Docker Compose build and up, and you're done. Maybe there's like some very, very minor steps in between, like, copy this example env file to a real env file, but that's it. And they just go on to say here that writing the code should be deterministic here. And that's really, really important when it comes to locking down your dependencies, right? You definitely want to have a version locked file. And, I did promise that we're going to be looking at some code here. For the first one, I kind of just skimmed over here that, yes, we have a Git repo here and all of this stuff is just sitting in version control. But, going back to talking about like explicit dependencies here, we have requirements.txt file here with Python. And we just have a very specific version for every single package that we want to have installed. By the way, I'm playing around with a new font here, and I'm not really a fan of using these literatures, whatever the heck they're called. But I'll probably change that in a different video. But I have this idea of like a requirements lock file here, and these are all the lockdown dependencies of every single subdependency. Likewise with the assets directory here, we have a package JSON file with our dependencies here, also version locked, but I happen to be using Yarn. So we have this lock file here that gets us going to make sure that we have basically very dependable builds. So if you were to clone down this repo and build everything, then it is going to use this lock file here, and you're going to be guaranteed to get all the versions that I had at the time of making that commit, even if you clone this 6 months in the future. Very important to have that. Very, very good stuff. So let's go back down to here and see where we're at. So they're talking about still bundle and stuff. So 12-factor X do not rely on implicit existence of any system tools. So examples include shelling out to ImageMagick or curl. Like these tools might exist on many or even most systems, but it's not guaranteed. Now, this one is kind of interesting. Like, they actually go out to say, like, if your app needs to shell out to a system tool, that tool should be vendored into the app. Now, prior to containers and Docker, that would have been a huge pain in the butt. But with Docker, this is so easy. Like these system-wide packages or system tools that we need, so easy to get going because we just go to our Docker file here and it's like, okay, here's the Python image What do we need in our system? Well, this is based on using Debian Bullseye as a base image. So we can see this as being just a normal, like run-of-the-mill Debian system here. What do we need? Well, kind of want to have curl installed. Great. Okay, it's in the Docker file. Now when my application runs, curl is going to be available. Likewise, libpqdev is also going to be available. If you're dealing with Python application, the psychopg2 Postgres database library requires having the system package libpqdev installed. I think Ruby also does as well. But yeah, these are just system level or site-wide packages that you want. Great, you have them and they're available always, and we're done. So let's move on to the third one, which is going to be store config in the environment. So an apt config is everything that is likely to vary between deploys. This could be staging, production, developer box, CI, whatever it happens to be. And this includes resource handling. Well, hold on, can I read? Resource handles to the database, memcache, and other backing services, credentials to maybe external services, such as if you're uploading files to S3, or maybe you're contacting Twitter over their API or something like that. But they could also have per deploy values, such as the canonical host name for the deploy. So in this case, we're going to look at some code very quickly, but canonical host names, perfect example. For Flask, if you happen to go to, I have a config file here, settings.py, there is a thing called a server name. So normally in development, I have this abstracted out with environment variables, which actually I think is talked about in that config factor. So we'll get into more details. But long story short, let's ignore the noise of parsing environment variables. The server name in development is going to be localhost : and then whatever the port it happens to be running on. But in production, this server name typically would be example.com or yourdomain.com or, whatever your domain actually happens to be. Maybe in a staging environment, you throw it into a staging subdomain. So you might have staging.example.com. So we just have this server name that is different between the environments, and that is just handled by a single config value. So I know Rails and probably Django and Phoenix and all other different web frameworks, they have very similar concepts where you can just set your base URL. The server name, of course, is going to be different depending on the actual name of the web framework that you're using, but the idea absolutely is common between all of that. So, they go on to talk a little bit more about, apps sometimes store config values as constants in the code. That's a violation of 12-factor. So they're talking about, in this case, imagine that we didn't have this config file here and we didn't have the server name there, but instead I went to, I don't know, maybe my app.py file or something like that. And I basically just hard-coded this value somewhere in the source code itself. That would be an extremely bad pattern because, well, if I had to this is not the spot for it, but if I had to go in here and change the server name to a different value, then that means my Git repo is going to change. And now suddenly, what do I do? This value needs to be different in dev versus staging versus prod. How does that even work if I have to make a change to the actual code and commit different versions of the code for each environment? That becomes an absolute unmaintainable mess. So very important to keep your strict separation of config from code. I really like that they bolded that because that's really what it comes down to. That's very core concept there. And then, config variables, they change across deploys, but the code itself does not. So a litmus test for whether an app has all config correctly factored out of the code is whether the code base could be made open source at the moment without compromising any credentials. And, it's actually valuable to read this because that's a really great point. Imagine, well, this application is open source, but, I have another open source Flask app, Build a SaaS app with Flask, which is a course that I have, where we build a real SaaS application with Flask. And that one happens to contact Stripe, and Stripe has API keys. And think how bad that would be. Imagine just open sourcing that entire application, applied to a real actual SaaS app that I have. And my production Stripe keys are just going to be sitting in the Git repo. Probably not a good idea. I wouldn't want to leak that information out. So yeah, very good to have these values all set up and not inside of your code, and also not commit to version control, at least for the secrets and stuff like that. So note that the definition of config does not include internal application configs, such as a routes file in Ruby. So let's see. I'm not really preparing anything here, but let me start tmux would be a little bit easier because I just want to jump to a different code example, what they're actually talking about, and then you can see what they mean. So this routes.rb file here is, well, yeah, so I was screwing around a little bit with this repo. Some of this stuff isn't even commit up back on GitHub because I was just testing out Turbo with Rails, but they're talking about basically having a single routes RB file here that just defines a whole bunch of different routes about your application. This wouldn't make sense to put into configuration. This wouldn't make sense to put, in a separate environment variable for each route. This is literally how your application works. And Flask in this case, there's no single routes file that's similar to Ruby. So that's why I jumped to the Ruby app. So Phoenix, if you happen to be using that, also has a very similar concept of Rails here where you have routes.rb. But yeah, they're just saying like that stuff doesn't really vary between deploys. Like the URLs are going to be the same, right? If you go to like /contact or /about, that is going to be the same in dev, staging, and prod in terms of the URLs at least. So another approach to config is to use config files that are not checked into version control, such as like a database.yaml file in Rails. Sorta, kinda, maybe. I guess it depends on how you implement it. Like for example, with Rails, I have this database.yaml file here, and I do commit this to version control. Why? Because I have all these different environment variables in here where, they're defaulting to things that are okay in development, like non-secrets. But, when it comes to production, yeah, none of these environment variables are like hard-coded into the file. I can use the same exact file for all my different environments, and it all works the same. Alternatively, you can also use a database_URL environment variable, and you'd be good to go. And none of that stuff is commit to version control. So yeah, just going back to here, this is an option, but I prefer doing it my way, not because I think the Heroku folks are wrong, but we're also talking 10 years in the future, like just different patterns. So the long story short, like totally agree with here. It's like a huge improvement over using constants that are checked into the code. But yeah, let's jump to maybe to the next paragraph here where they're just talking, about storing configs values in environment variables. And I am a very, 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 very big fan of that. So environment variables are very easy to change between deploys without changing any code. So config files, yeah, there's a little bit of a difference there because there is little chance of them being checked into the code repo accidentally. Well, they're talking about environment variables there, and unlike custom config files or other config mechanisms, such as Java system properties, they're language and OS agnostic standard. So they're talking about environment variables here. And what's really nice about that is, yeah, so going back to the Flask app, if you were to clone down that repo, you get an env.example file. And this env example file is really wired up to be very nice for development. So the idea is you can just clone down the repo, copy this env example file, which instructions are in the README, to just a regular env file. And you can see this is the real env file. So in development, all you had to do is just, copy that file over and up it, because there's going to be certain things in development that you'd want to set. Like, I want my Flask env to be development, and I also want to have, at least some secret key set, but I could run this command here to get a really good value for prod. So like my philosophy around environment variables and config in general is, when possible, I like to have these values default to what they would be in production, and then I'll overwrite them in development. Now, like in this case, if I'm running a local version of Redis, this is actually the production value because it's just running in Docker Compose and just another service in the Compose file. But things like the server name, well, this is an open source project. I have no idea what domain name you're going to have. It's going to be different based on your project. So like defaulting to localhost there makes sense. So got to use your discretion, but that's generally my philosophy on that one. And now, they talk a little bit here about like config management around grouping them. So I know with Ruby on Rails, there's different environment config files that you can set for like development, test, production. They even say like that's specific to Rails, but other frameworks have this as well. I kind of do agree with them that method is not super scalable. I guess like as more deploys of your app are created, like let's say you want to make a QA environment, well then suddenly you need to remember to make a QA config. So going back down to here, in this config environments folder, you have development, production, and test. And a lot of the values in here are totally safe to set, in version control, like they're just not, there's no secrets and whatnot. But we have, similar values in production. And I guess this is what they're talking about, where it can get kind of easy to accidentally just get mixed up or, just have the wrong value by accident. Like for example, like eager loading is set to false here in development because you wouldn't want to eager load maybe all of your code when it boots up in development, but in production, totally want to have that. But an alternative to this pattern is, maybe in your env file, you just add a new environment variable called like eager load, and then you just have that set to true or false. And you actually remove these independent values from each individual config file. And then in the Rails case, you can actually put generic config values that apply to all environments in your application.rb file. So that'll be up to you, depending on what web framework you're using and whether or not you want to go down that rabbit hole of doing all of that. But at the same time, these factors are not set in stone, like it's not an all or nothing thing. So maybe it's just easier, or maybe the web framework like really puts you down this path of doing it this way. And it's not like you're sitting there adding new environments like every 15 seconds or something, right? You're probably going to have maybe test, QA, like dev, prod, like they're not changing that often. So having them here is actually just quite a lot more convenient than making like a million different environment variables. And then, in this case, I'm trying to look for maybe an example here. But yeah, like this one, it expects an empty list, and like that needs to be, I guess that's like an atom or whatever symbol they want to define that as. But, you'd have to like convert that environment variable that's as a string into this data type here, which would be a list or whatever. And it just becomes more of a nuisance, right? So you got to be pragmatic about some of these choices as well. But 12-factor apps, environment variables are granular controls. Like that's still a very good idea. I would definitely apply to that. And just going back to the Flask example here, there only is this one config settings.py, and everything that's different between each environment ends up being an environment variable. That's what an important takeaway. So let's move on to the next one. So the next one is backing services. Treat backing services as attached resources. So a backing service in this case would be any service the app consumes over the network as part of its normal operation. For example, that could be MySQL, Postgres, CouchDB, or you could use something like RabbitMQ, or maybe you're using Redis, or whatever examples that they have here. For SMTP services for mail, you could be using Postfix, or again, they're talking about caching systems here, Memcached. So backing services like the database are traditionally managed by the same system admins who deploy the app's runtime. In addition to these locally managed services, the app may also have services provided and managed by third parties. For example, when it comes to sending email, chances are you're probably not going to be running Postfix yourself, right? You're going to be using some third-party service like SendGrid or Postmark or Mailgun or, whatever preference that you have. Maybe if you're on Amazon, AWS, maybe you're using SES, like lots of different options here for third parties. Likewise, when it comes to gathering metrics, New Relic is really popular there. There's also things like Datadog, and also when it comes to logging, they use Loggly as an example there. There's also Datadog there as well. Maybe you're using Sentry for exception handling and stuff like that. All different third parties here. And let's see, they also talk about API accessible consumer services like such as Twitter. Maybe you're using Google Maps API or Last.fm. Wow, haven't heard that in a long time. That was some music streaming site from, I guess, back in the day. Let's see if they actually still exist. Oh, they do. Nice. Cool. That's maybe another journey for another time. So the code for a 12-factor app makes no distinction between local and third-party services. To the app, both are attached resources accessed via URL or other locator credentials. Like, I remember reading this a while back. I'm pretty sure what this really just translates down to is it shouldn't be hard for you to switch between, let's say, a local version of MySQL versus maybe you're running MySQL on RDS if you happen to be on AWS or something like that. You shouldn't have to make application changes for that. It should just be as simple as changing your database URL. Likewise, when it comes to other stuff as well, it should be really easy. Like, prime example, they use Twitter here, but, let's talk a little bit about Stripe. Maybe you are dealing with some billing stuff. If you happen to be using Braintree, I guess it's going to be very similar, where you just have the idea of having test keys as well as production keys, or test and live, or whatever you want to call them, where you shouldn't have to change your code to switch between the test keys and the prod ones. They should just be environment variables that are just sitting there in your env file. And the only difference between deploying to maybe a staging environment where we're using the test keys versus the prod one is just, the key value. That's it. That's no code changes. So that's basically, where I think they're going down to with this one. Right. Yeah. So they're saying like the current production database could be detached and the new database attached, all without any code changes. So just changing an environment variable. Now, I don't know if they're literally talking about like changing this in the sense like live, like hot swapping a different database without restarting the service. I don't think they're talking specifically about that because, they're really focusing on without the code changes, and environment variables let you do that. So let's move on to the next one where they're talking about strictly separating the idea of build and run stages. So a code base, it could be transformed into a non-development deploy through 3 stages. So we have the build stage, the release stage, and the run stage. And the build stage, it's transformation which converts a code repo into an executable bundle known as a build. Now, I'm actually not like majorly experienced with Heroku, but they have these ideas of like build packs and stuff like that. Like it's basically a bundle of your thing, the thing that you're building. And if you're working with Docker, Well, that's also very transferable to this similar build stage, except instead of having a Heroku build pack that gets built, you just have a Docker image that gets built. So using a version of the code at a commit specified by the deployment process, such as blah, 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 you have all your vendor dependencies, everything down, compiles down to, or if you happen to have binaries that needed to be compiled, as well as assets. And let's talk a little bit, I guess, about the next thing, which is the release stage. So that takes the build produced by the build stage and combines it with the deploys current config. So the resulting release contains both the build and the config and is ready for immediate execution in the execution environment. This is pretty interesting. You're taking, let's say, a very specific Docker image that you built. Let's just call it V1 or something like that. And then you have your current config. Now, this config is not going to be built into the image itself because those environment variables, you wouldn't want to have them built into the image because they may contain secrets and stuff like that. If you put that Docker image up on a Docker registry, like the Docker Hub or, ECR and AWS or something like that, you don't want to have those things just sitting there, on disk inside of your registry. Not that the Docker Hub is going to do bad stuff potentially, but like just from a security best practice, absolutely good idea to have those configs like outside of the actual builds. And then, you just insert those environment variables securely or config files securely into the runtime here. Well, I guess they get to that eventually. But yeah, the takeaway there is the release stage is basically a combination of, your current config at that point in time versus your actual like V1 build tag or whatever you decided to do. Now, let's talk next about the run stage, also known as runtime. And by the way, we're on step 5 of 12, just to give you an idea. Okay, so this runs the app in the execution environment by launching some set of the app's processes against a selected release. So maybe that will be a little bit easier if we just maybe start just moving forward here, and we'll see how they all tie together here, because you can see here you have your source code sitting in your Git repo there. Then we have our build artifact. Let's just call it a Docker image v1. Then you have your config, and like the idea of combining both of those like things as a description of something is called the release. And yeah, the 12-factor app uses strict separation between the build, release, and run stages. And this is, again, awesome example of just how this stuff transcends over different technologies, right? Just because we're using Docker now, like these things still apply, and we just like swap out, the build part, right? Because instead of building like a build pack with Heroku, or maybe if you're going, I don't want to say old school, but maybe you're rolling up your own like Debian package or something for your application if you're not using containers or Heroku or something like that. Like that's something exact same concept, just applied to a different tech. Now, for example, it's impossible to make changes to the code at runtime since there's no way to propagate those changes back to the build stage. That makes total sense, right? If you have a running application or something like that that's released and it's up and running, you wouldn't necessarily want to just go in there and like change code. Now, I know because that, that's no longer the build that you deployed. It's some other crazy random thing that you did like off to the side. Now, I understand that there are some tech stacks that sort of kind of maybe allow you to do that in sort of friendly ways, like PHP, right? You just put a new file somewhere on the file system, and the next time Apache serves that request, it's going to do the new one. Like there's no like restarting of things that you have to do. So technically, I guess you can do these things with other languages, but whether or not they're a good idea, well, I was going to say maybe it's debatable, but like when is it ever a good idea, right? It's like, if you're going to release something new, that should go through the whole pipeline of making a new build, and I get it. You're probably like, Nick, but what about like hot fixes for like emergencies or whatever? Like, yeah, I mean, the idea here is like roll forward, like make a new build and release that. So deployment tools typically offer release management tools, most notably the ability to roll back to a previous release. For example, Capistrano, that's a very popular tool in the Ruby ecosystem for deployment. I remember using this one way back in the day, and I don't mean that in like a condescending way, like, oh, now I've moved on to better things or whatever. Like it's still a really good tool. It doesn't fit into what I need anymore. But they basically, go over just some examples of how this works here. I don't have a Capistrano example to show you here, but we can focus on some good stuff. Like every release should always have a unique release ID, such as maybe a timestamp or an incrementing number, such as like a V1 or V2 or whatever. Could also be maybe a Git SHA as well, right, to a specific commit. Or if you want to name that commit, you can also tag it to something more human readable, like a V1 or a V2 or something like that. So releases are an append-only ledger. So that's a really important thing too, right? A release cannot be mutated once it's been created. Basically, you don't want to go and change it after the fact. Any changes, you must create a new release. So going back to here, you wouldn't want to change that release, make a new one, in your code, whatever you plan to actually change in that release, then make a new build, and then there you go. You're always like moving forward. It's append only. So these builds are initiated by the app's developers whenever new code is deployed, right? Runtime execution. Well, brain just froze there. Yep. Runtime execution, by contrast, can happen automatically in cases such as a server reboot, or maybe something crashed, or the process manager just decided to restart, something like that. Now, therefore, the run stage should be kept to as few moving parts as possible, since problems that prevent an app from running can cause it to break in the middle of the night when no developers are on hand. The build stage can be more complex, since errors are always in the foreground for a developer who is driving the deploy. Okay, so let's unwind that a little bit here. So when it comes to something like the build stage, in most modern systems, and I'm also not saying like, well, if you don't do this, then you're not modern, but in a lot of cases, you are going to have your build stage happen in a CI environment, right? Maybe you're using GitHub Actions or Bitbucket pipelines, or you can, whatever GitLab has with their runners, whatever they have it named. Or it could be as simple as maybe you're not using CI and you're just running your Docker Compose build like directly on your dev box and just pushing it directly to a registry there. All viable options depending on your use cases and comfort and, team sizes and, many other different variables that you might have. But yeah, the build stage, it could be basically as complicated, I guess, as you need it to be, because ultimately you are going to be aware of what happens before that ends up being released, because it's either going to like fail on your dev box when you build it, or it's going to fail in CI. So yeah, let's move on to the next one here, where we're going to talk a little bit about processes. So execute the app as one or more stateless processes. This one I definitely like. So the app is executed in the execution environment as one or more processes. So in the most simple case, the code is a standalone script. The execution environment is a developer's local laptop with an installed language runtime, and the process is launched via command line. So, imagine you just had a completely standalone little Python script that said hello world, and you run Python 3. Back then, I don't think 3 existed, but you'd run Python 3 and then you'd run your script and it would print back hello world. So on the other end of the spectrum, a production deploy of a very sophisticated app may use many different process types initiated or instantiated into 0 or more running processes. So they really want to drive home here that 12-factor processes are stateless and they share nothing. So any data that needs to persist must be stored in a stateful backing service, typically a database, or maybe you're caching something to Redis or Memcached or whatever your weapon of choice there is for persisting this sort of stuff. Likewise, if you're persisting some files, like maybe you want to upload them to S3. So the memory space or file system of the process can be used as a brief single transaction cache. So what they're talking about there is like, let's say that you are dealing with, like user avatars or something like that, and a user uploads the avatar. You can totally write their upload to disk, and then maybe you want to do something to that image, right? Maybe you want to, desaturate it or resize it, or maybe make a couple thumbnails from it. Totally do that. And well, actually, let's see what their example is here. So for example, downloading a large file, operating on it, and storing the results of the operation in the database. Right, very similar example, right? No harm in that, even in the 12-factor like philosophy. So, but the 12-factor app never assumes that anything cached in memory or on disk will be available on a future request or job. So with many processes of each type running, chances are high that a future request will be served by a totally different process. Even when running only one process, a restart triggered by code deploys or config changes or the execution environment relocating the process to a different physical location, that's going to usually wipe out all the local memory and file system state. So long story short, very, very, very important to basically treat your file system as if it's just some temporary thing that you can write to for the duration of your request. But as soon as your web server or whatever returns a response, the next request that you do, you can't assume that there's going to be something in that file system. So basically just treat it as it doesn't exist for storing anything long-term. So asset packagers managers like Django Asset Packager use the file system as a cache for compiled assets. 12-factor app prefers to do this compiling during the build stage. Never used this asset packager now. We're also 10 years in the future. Pretty sure Django has collect static now that is very similar to what they recommend here and in the build stage. And I know we haven't looked at code in a bit. Like the other ones, like this one over here, nothing to really look at. But in this one, we could totally look at a couple examples here. So in terms of the build stage, like this Docker image that we're looking at here is part of the build stage. And in there, we can see that when the Flask environment is not development, so maybe it's staging, maybe it is prod, maybe it's something else, then we do a Flask digest compile. Now, this is an extension I actually wrote that does MD5 hashing or digesting your static files. But like this is the build step. This is doing the same thing in Rails if you're more familiar with that. It's doing a precompile of your assets. Where is that at? It's up here. Yeah, so assets precompile here. So this is in the build step. We're building our assets at build time, and that's exactly what the 12-factor methodology says here for this one. Yeah, done. So some web systems rely on sticky sessions. That is caching user sessions data in memory of the app's process and expecting future requests from the same visitor to be routed to the same process. Sticky sessions are a violation of 12-factor and should never be used or relied upon. Session state data is a good candidate for a data store that offers time expiration, such as Memcached or Redis, right? So, if you're not using like encrypted signed cookies for certain things, like for your session, just storing them client-side in a cookie, you may actually want to just use Memcached or Redis. So a lot of web frameworks, they can definitely let you just pop Redis in as a backend and your session data will be written there. It's a really good idea. And, Redis or Memcached, it's a reasonable place for that one, because if that session data goes away, then it's not like the end of the world. It's not like you lost an invoice for a payment. Then the user just logs in again. And, normally it's not like you're restarting Redis or Memcached on a daily basis or restarting it in unison with your code deploys. This instance of Memcached or Redis, it could be running for potentially a very long period of time, maybe in between version bumps, like, upgrading Redis from a different version or something. So yeah, good idea to store that stuff server-side in Redis instead of, in the process memory or something like that. So now let's go on to and by the way, if you're wondering what my preference is for like, should you save it client-side in a cookie or maybe in Redis session backend, really depends on what you want to do. Maybe that's a total potential entire video topic of its own. So let's abort on that idea because this video is getting already kind of long, but where are we at here? Yeah, we're a little bit more than halfway. So port binding, export services via port binding. Web apps are sometimes executed inside a web server container. For example, PHP might run inside an Apache module, or Java could be running inside of Tomcat. So a 12-factor app is completely self-contained and does not rely on runtime injection of a web server into the execution environment to create a public or a web-facing service. The web app exports HTTP as a service by binding to a port and listening to requests coming in on that port. It's a lot of words, and we'll get to an example soon here. But they say in a local dev environment, like developers, you can just go to something like localhost port 5000 and access the service exported by their app. In deployment, a routing layer handles routing requests from a public-facing hostname to the port-bound web processes. So let's look at some code really quick here. If I jump back down to that config file we were looking at before, well, different config file here. Well, technically it starts here, I guess, in the settings one with the server name. We have localhost here reading this port 8000. Let's just say it defaults to that, even though technically you can override that by passing in a different value through the environment variable. But yeah. Well, actually, no, let's go back down to here. So this is the Unicorn config file for the web app server running, just Unicorn. So this is a really good web server for Flask and Django. And it has this idea of, you can just bind to a specific IP and port. In this case, it's port 8000, 0000, so anyone can connect to it technically, but we're also protected by Docker there. We need to basically publish this to the outside world so we can access this outside of Docker's universe. And, in this compose file, I am doing that down here in, here we go. So this port forwarding. So we're actually forwarding it just to localhost. This is all going to tie together in a second here. But basically, I'm a big fan if I were to be running, well, actually, before we get into that, on my dev box, like if you clone this repo and ran it, you can just do, compose up, and then you can go to localhost port 8000. Likewise, same thing with the Rails app or any other example app that I have. So we adhere to their factor. And in this case, it's limited to only allow connections from localhost, because when I deploy my apps to one server, I am a huge fan of just running Nginx directly on my Docker host. I have a whole big blog post about why I prefer running Nginx on my host directly and not inside of Docker. But this just limits things so that, only Nginx is able to connect to this. That's basically the routing layer, if you want to call it that, rather than the entire public internet without depending on something like a cloud firewall. Lots of details there, I know, but that blog post that I wrote about there, it helps. But the basic idea is, yes, run your web server or app server independently like this. You can connect to it fine, just in development, localhost, port 8000, whatever port that you want. And then, the routing layer is like now a problem that the web app doesn't need to worry about. You could have Nginx just hosting things on a single server. Maybe you have an AWS load balancer in front of that. Like if you're on Heroku, they have their own router layer, in front of that. And like This can actually map like your public-facing hostname, example.com, to your port-bound web process. That's basically what they're getting down to here. So that's typically implemented by using dependency declaration to add a web server library to your app. In this case, this could be Gunicorn if you're using Flask or Django, or it could be something like Puma if you're using Ruby with Rails as well. I know there's also Unicorn. It's another option there too. So they talk about other ones well, like for Tornado for Python, Thin for Ruby. Again, we're dealing in a world where 10 years ago. But Tornado, I guess, still technically maybe usable. I don't know if folks use that nowadays. I'm not really sure. I've always used Unicorn and it's been great. But this says this happens entirely in user space, that is within the app's code. So the contract within the execution environment is binding to a port to serve requests. So they also say here, like HTTP is not the only service that can be exported by port binding. Nearly any kind of server software can be run via a process binding to a port and waiting for incoming requests. Examples include eJabber for XMPP and Redis, speaking on the Redis protocol. Yeah, not super important here, but you can go to something like Redis:// if I actually jump back down to here. They're just talking about that. So like instead of the HTTP protocol, you could be going to Redis like that, or there's one for Postgres. If you use MySQL, there's one for that as well. So that's kind of what they're talking about there. So note also that the port binding approach means that one app can become the backing service for another app by providing the URL of the backing app as a resource handle in the config for the consuming app. Perfect example, right? Yeah, if going back to the example here, if this application were composed of two separate services or something like that, then yeah, you can just connect to the other service. I guess technically that's like what we're doing here. We're connecting to Redis over the Docker network, but that could be another, Flask app in its own completely separate code repo that you just connect to over like an internal host name or something like that, or maybe an internal load balancer if you have that set up. So lots of options there. Now let's go to the next one. And they're talking now about concurrency. And I will need a drink, so I'm going to cut the video, and we're back. So concurrency, scale out via the process model. So any computer program, once run, is represented by one or more processes. Web apps have taken a variety of process execution forms. For example, at PHP, you can run child processes of Apache, started on demand as needed by request of volume. So Java, they take a different approach here, where you have JVM providing one massive Uber process that reserves a large block of system resources, CPU and memory, and then concurrency is managed internally. Whether that applies to nowadays with Java and the JVM, I don't know if there's different options. I am not a Java developer. Let us know in the comments below if there's other alternative means. But in both cases here, they're talking about the running processes are only minimally viable to the developers of the app. So the 12-factor app, they say processes are first-class citizens. So in a 12-factor app, take strong cues from Unix process model for running service daemons. So using this model, the developer can architect their app to handle the various workloads by assigning each type of work to a process type. And by the way, we're going to tie all of this together here. I'm just going through some stuff here. But we can see here too, there's different ways of scaling. You can just scale up basically vertically, where you just might add more workers. But before we get into workers, let's just finish up the reading here. They say that, for example, HTTP requests may be handled by a web process and a long-running background tasks handled by a worker process. So there's our web processes there, and there's the worker ones there. And we do have examples of that in both the example Flask app and Rails app. So if I go to the compose file here, then we do have the idea of a web service as well as a worker. And in this case, the web service is the Gunicorn application, the web app. And for the worker, happen to be using Celery here. That's a very popular background processing job queue for Python. It works with Flask, Django, basically any Python language or any Python-based web framework, or doesn't even necessarily need to be a web framework, but yes, Celery, great option. And with Rails, we've got a very, very similar setup here. But in this case, the web one happens to be Puma. That's like a direct, swap in replacement to Gunicorn if you're just talking about different web servers across different languages. And then also you have the worker here. In this case, I happen to be using Sidekick. You could be using Delayed Job or Rescue or potentially other ones as well. But Sidekick is very comparable to Celery in the regards of, yeah, they're both really good background workers for their respective tech stacks. Yeah, we should be able to completely independently scale them vertically and horizontally. So maybe we just need 2 copies of the web app running, but we need 4 workers. Like, we should be able to do that. And we can do that because using that pattern we just looked at over here, they're completely separate processes. So, in this case, the example apps are set up to run on one server where you just do Docker Compose up and you get 1 copy of each one. But if you were running on maybe Heroku or running on Kubernetes or some other, container orchestration platform, you'd have the ability to dial these things up and out. So out means basically adding more of them, and then up talks about just giving yourself more resources. So, you might have a VPS with 2 gigs of memory and 2 CPU cores. If you're going to scale vertically, well, maybe now you have something like 16 gigs of memory and 4 CPU cores. But then horizontally, you would be like, well, now instead of having 1 of those servers, maybe I have 5 of them. So yeah, well, I guess this chart doesn't really reflect the vertical in that regard and horizontal in that regard. That's workload diversity, but you get the idea. And I guess we got a little bonus side topic there. But they're talking here too about like this does not exclude individual processes from handling their own internal multiplexing. For example, if we're using Node.js, right, they have the event loop there. And then if you're using something like Phoenix and Elixir, there's the actor model there. Can't get into all that for the sake of time, but these are alternative methods where internally, then instead of spinning up something like, 5 unicorn workers or something like that, you can just deal with Node's event loop, or you can just have Elixir handle all of that internally using the Beam VM there to do all of its work. But an individual VM can only grow so large, vertically scaling, so the application must also be able to span multiple processes running on multiple physical machines, right? That's the idea of horizontally scaling out. And then, you can do things like where you might have 5 copies of your app running and then a load balancer in front of them. And the load balancer would be like, okay, cool, let's send traffic to server 1, 2, 3, 4, 5, maybe round robin, like lots of different options there. But that's how all that stuff comes together. So the process model truly shines when it comes time to scale out. The sheer nothing, horizontally partitionable nature of 12-factor app processes means that adding more concurrency is a simple and reliable operation. And they are totally right there. I mean, scaling out is never an easy task. Especially if you have something like a legacy application or whatever, and you're not used to creating this idea of like a stateless application with nothing being shared, it can be kind of hard at the application level to like refactor your app to be set up to do that. But, the concurrency model itself, technically it's pretty simple and very reliable, because it's like, well, if I have 2 of them and I need more, then I just add a 3rd one. And then the load balancer is like, all right, cool, there's like 3 of them in rotation now instead of 2. Like, it is a very simple model in that case. So the array of process types and number of processes of each type is known as the process formation. Whatever, 12-factor app processes should never demonize or write PID files. Instead, rely on the operating system process manager, such as systemd, a distributed process manager on a cloud platform, or a tool like Foreman in development to manage output streams, respond to crash processes, and handle user-initiated restarts and shutdowns. Okay, lots of good stuff here. Lots of things, maybe, I don't know if you've heard about these things, but also lots of spots where Docker and Kubernetes will really take over here to help things out quite a lot. So when you, first of all, they say 12-factor app processes should never be demonized or write PID files. Totally makes sense. And in our case, when it comes to running stuff in Docker, like this Unicorn web server, it is technically running in the foreground. It's not demonized. It's not running in the background. It doesn't have its own PID file sitting somewhere. It just runs in the foreground because that's the protocol Docker expects. So if I go to the Docker file here, and this applies, well, we're looking at the Ruby app, not the Python one, but same exact concept, just different applications here. But Unicorn here, yeah, it's just running in the foreground. Docker consumes that, and Docker in this case is basically, for argument's sake, a replacement to systemd. So it is essentially the process manager. So instead of systemd, which is, potentially, well, it is a very good process manager that you might use if you're not using Docker. Docker just replaces that. And, distributed process manager, maybe you're running on a Kubernetes cluster somewhere on the cloud. And then in terms of tools like Foreman, well, that's a very popular tool that allows you to multiplex different outputs to one terminal. Not in the sense of how Tmux would, but a good example would be here, Docker Compose is a completely separate or completely drop-in replacement for Foreman, because we have these different services. We have Postgres and Redis and Web and Worker. And if I actually do a Docker Compose up here, I don't know, I haven't built this in a while, so if this fails, whatever, but it doesn't matter. We can definitely at least see the outputs here. So we have those, multiple different services that we have in that Docker Compose file. And look at that. We have all this different output here coming through one terminal. So there's the one for CSS and Postgres that's coming from a different file. I've done videos about this in the past, like my Docker best practices talk from DockerCon. I'll leave a card up for that one. But you can see here, there's the one for Postgres and Redis, and there's the worker, and there's web, and they're all just like output here as one stream. So going back to here, that's exactly what they're talking about here. But Foreman is a tool you can use if you're not using Docker to get that effect. And there is, I think, ports of that for Python as well. I think it's called like Honcho instead of Foreman, but it's a very similar tool. So let's go to the next one here, which is Disposability. We need to maximize robustness with a fast startup and graceful shutdown. Lots of buzzwords, but also very important stuff. So 12-factor app processes are disposable, meaning they can be started or stopped at a moment's notice. This facilitates a fast elastic scaling, rapid deployment of code, or config changes, and robustness of production deploys. We're going to get into more details about that here, but processes should strive to minimize startup time. And yeah, that I think we should stop and talk a little bit about that one, because part of what I do, like in the morning, that's fun to me is, I'll look at some like Hacker News sites and various different subreddits about the web technologies that I care about, like Flask and Rails and a couple other ones as well. But oftentimes I will see, I'm not calling anyone out specifically here, some questions about Docker. And, folks will sometimes recommend that you do something like build all of your assets in a Docker entry point, which means like when every single time your container starts, then you're going to run something like a precompile assets with Rails, or static collect static with Django or something, and it's going to take like 30 seconds. Like that is not the spot to do that. So you definitely want to minimize startup times by doing those types of things in the build stuff that we talked about before. So ideally a process should take seconds from the time it takes for you to just launch the command until it's up and running and ready to receive requests or jobs. Now, it would be nice if every single process in the world started in a few seconds or less, but this is really going to depend on whatever tech stack that you're using, right? And if you have a really, really, really big Rails app, a couple million lines of code, it's going to take a lot longer than a couple of seconds to start up. But yeah, if you have like a, super optimized like Go binary, that may take like 200 milliseconds to start up. So it really depends on the size of your application. But takeaway there is definitely do whatever you can to make that startup process as fast as possible, because that ultimately will allow things like rapid deployment, because going from starting in 2 seconds versus 20 seconds, but you need to start like 50 of them in like a rolling fashion, it's going to be a really big difference in time from going from 0 new versions of your app to all 50 of them if it takes 2 seconds instead of 20, etc. So startup time provides more agility for the release process and scaling up, and it aids robustness because the process manager can more easily move processes to different machines, when warranted. So not that much code to look at for this specific part, but also like this part here, like process shutdown gracefully when they receive a SIG-term signal from the process manager. So, if you're using systemd, or you happen to be using Docker, or you happen to be using Kubernetes, when it comes to a SIG-term, well, let's see what they have to say here first. Like for a web process, its graceful shutdown is achieved by ceasing to listen on the service port, thereby refusing to accept any new requests, allowing current requests to finish, and then exiting. And implicit in this model is that HTTP requests are short, no more than a few seconds. Honestly, nowadays, I would strive for a lot less than a few seconds. I would try to respond, if possible, within 150 milliseconds. Or in the case of long polling, the client should seamlessly attempt to reconnect when the connection is lost. Long polling is an option, but nowadays, I guess if you wanted long polling like behavior, you'd probably end up using like a WebSocket connection. But very similar in that regard. But when it comes to something like sending a SIG-term, depending on what web framework or what web app server that you use, there are ways to basically capture this signal that comes in. So like in the case of gUnicorn, I actually don't have an example of this offhand here in my gUnicorn config, but there are different gUnicorn hooks that you can hook into. So basically a hook, like when this process event happens, like a SIG-term is sent from Docker to, let's say, gUnicorn can have a hook there, basically just a function that gets run to, do whatever you need to do to clean up some certain things. So that option is there for a lot of different web app servers in many different languages. But it's important to keep tabs on that. And then the actual process manager itself, like Docker or Kubernetes, usually they have some options like, a graceful shutdown period of time. Like usually it could be like, I don't know what it is by default, right? 30 seconds, 15 seconds, something like that. But, it should be fairly fast, like basically the least amount of time that you need for it to shut down without causing like data corruption or something crazy happening. Now, for worker processes, and by the way, a SIG term is much, much different than something called like a SIG kill. So a SIG kill coming from a process manager, that is basically, it's a death touch, right? It is going to just terminate your Unicorn web app server with no chance of your web app server to say otherwise. Like there's no cleanup, there's nothing. It's immediate death. No warning, zero warning. Whereas SIG term is so much nicer. SIG term is like, by the way, I really like you, but can you please shut down in this period of time? I would really appreciate that. But a SIG term is just like, you're dead, and that's it. So let's talk now a little bit about worker process. A graceful shutdown is achieved by returning the current job to the worker queue. I mean, this also, I guess, is sort of kind of specific to depending on what tech stack you're working with, because not every tech stack really has the notion of running like a separate background worker. But, in general, if you are and you have a work queue, like, I don't know, whatever work that needs to be done in your application, you should definitely you should definitely handle what happens when someone sends a SIG term to that worker process, because, you don't want to have to redo jobs potentially. So I mean, this gets really deep now. Like you might want to save the state of your job in a persistent database. Like you might want to save stuff. Like you want to make sure that they're unique. And if you run them twice and it's partially complete, like what happens then? So there's like a million edge cases to go around there. But they go on to say here, like for example, on RabbitMQ, the worker can send a knack. On Beanstalk D, the job is returned to the queue automatically whenever a worker disconnects. You have lock-based systems like delayed job. That's like comparable to Sidekick in the sense that they're both background workers for Ruby. They need to be sure to release their lock on the job record. Implicit in this model is that all jobs are reentrant, I guess, like that's not a word I'm used to seeing, which typically is achieved by wrapping the results in a transaction or making the operation idempotent. Right, very good there, right? Because you might need to end up running that job 3 times. So idempotency is basically you run it once, cool. You run it 10 times, same result as running it once. Like you're not going to get 10 different results. So the idea is after you run it, like continuously running it shouldn't provide different results. So processes should also be robust against sudden death, right? That's what happens if you send a SIG kill instead of a SIG term. So in the case of a failure in the underlying hardware, right, like maybe your drive just like immediately just stops working. While this is a much less common occurrence in a graceful shutdown with a SIG term, it can totally still happen. So a recommended approach is use a robust queuing backend, such as Beanstalk D, that returns jobs to the queue when client disconnects timeout. This is really going to depend on what tech stack you use. Certain background tools or background worker tools, like I think you can do this with Sidekick Pro, right? It's going to really depend on your tech stack. But either way, a 12-factor app is architected to handle unexpected, non-graceful terminations. Cross-only design takes this concept to its logical conclusion. Now, you can see here, I'm not going to click all these links, but cross-only design, that's a clickable link. That may be something that you may want to read on your own. So lots of good stuff in this. And it's awesome because this is such like a concise thing, like 1 or 2 pages, but there's like a lifetime of information here. Like I've literally been applying these concepts to all the apps that I've been building, like since I read this back in, I don't know, maybe, I don't think I read it like day 1 in 2011, but probably very shortly after that. So let's go down to the next one here. Wow, this video is long. Dev prod parity. So we want to keep our development staging and production as similar as possible. And, in terms of like looking at code to make this happen, we sort of went over that a little bit before, right? We have technically one config file with environment variables that differ between the environments, but there's a lot of dev prod parity. Just coming naturally from using Docker, right? Having everything built into a Docker image that we can run on Mac, Windows, Linux, all the same, and then prod also all the same. Very good stuff. Let's see what they have to say though here. So historically, there have been substantial gaps between dev, a developer making live edits to a local deploy of the app, and production, a running deploy of the app accessed by, customer-facing users here. So these gaps manifest in 3 areas. The time gap. A developer may work on the code that takes days, weeks, or even months to go into production. Hopefully not months. The personal gap. Developers write code, ops engineers deploy it. And then you have the tools gap. Developers, maybe using a stack like Nginx, SQLite, and OS X, while the production deploy uses Apache, MySQL, and Linux. Right. So this problem is very easy to solve by using Docker because, if you're using Mac OS or Windows or Linux, and yeah, in production, you're probably going to be using some Linux distro, maybe Debian or Ubuntu, etc. You can run these same tools both in dev and prod, and it's just, completely factored out by Docker. So very nice. And yeah, when it comes to the time gap, these are all, well, I don't want to say personal opinions, but yeah, my philosophy on this one, yeah, developers and operations should be working together to basically deploy stuff very quickly. Like, it is much, much safer to deploy a very small, tiny incremental change and repeat that many, many, many times versus just waiting like 2 months and then deploying, 15 branches worth of commits in one shot and then just hope for the best. So yeah, I don't know. There was some quote I read somewhere around just like the way that you be less afraid of doing something, or the way you make something easier to do, is by keep on doing it, right? So just deploying 18 times a day with tiny little patches, way better in my opinion than just waiting months and months and months and doing it once in a while. Like, you don't want to put it off like because you're afraid of it. Like, do it so much that you get really good workflows that doing it is like whatever, business as usual, non-event, trivial, like no problem most of the time. I mean, there's database migrations where that's like always pretty scary, but yeah, you get the idea there. So let's talk a little bit about the next stuff here. So the 12-factor app is designed for continuous deployment by keeping the gap between dev and prod small, right? We want to have that small as possible. And even going back to here, like, you might be wondering, am I using Gunicorn in development? Absolutely I am, because I'm using it in production. Like, why would I use the Flask dev server when Gunicorn works just as well, if not better? I mean, it's like a proper web server. It supports code reloading here, and good example of, dev prod parity. Well, this one config file works the same. Sorry, just kicked my mic here. Works the same in dev and prod. So I want to have code reloading for the web servers in development, but in production, it defaults to false. But if I go to my env file here and scroll down here, it's set to true. So in development, yeah, I get code reloading. I can just, go into my application, change whatever HTML templates, my, Flask code, Django code, Rails code, all the same, similar concepts for all of them. And I get that reload in, as fast as my eyes and hands can move to the browser to reload. But in production, yeah, we don't have code reloading, which is good. But yeah, dev prod parity basically. So looking at the 3 gaps described above, make the time gap small, right? A developer may write code and have it deployed hours or even just minutes later. Great. Like, I actually, I haven't read these in a long time, but this came up for some work recently. So I figured it would be nice to make a video about this now. But yeah, very, very, very important to have the capability of doing that. Now, that doesn't mean you need to deploy multiple times a day, but the ability to do that is really nice. And it really should just be like, developer commits code to a PR. Maybe it gets, hopefully it gets reviewed by somebody else. Then it gets merged into whatever main branch that you have. That triggers things to eventually get deployed. And like the rollout of the deploy hopefully happens within a couple minutes. Now, I'm, hand waving over stuff like CI, running linting tools and formatting and testing and building images and stuff. But yeah, it should be an automated process that doesn't take long. Now, make the personnel gap small here. Developers who wrote code are closely involved in deploying it and watching its behavior in production. Such an important concept. Like, it is so good to have, wow, this one's pretty long, okay? It is very, very nice to have, yeah, little small teams, like, maybe 3, 4, 5, 6 developers, whatever, who totally own their code from dev to prod. Now, whether or not they have like, a DevOps engineer or like a site reliability engineer like on their team or something, depends on the organization, how you have things structured or whatever. But yeah, it should totally, the developers should be in a position to at least, monitor the behavior of what they deployed at the very least. So yeah, make these tools gap small. Again, Docker just really, really helps us there. So now they just summarize the above into a table, basically. Time between deploys, traditional app, yeah, it could take forever. 12-factor app, we want that to happen in hours. Different people, 12-factor app, same people for who's deploying it versus building it. And then dev prod parity could be very divergent in like an old legacy style app where a 12-factor app is similar as possible. And backing services such as the app's DB, queuing system, or cached, in one area where dev prod parity is really important. Many languages offer libraries which simplify access to the backing services, including adapters to different types of services. Some examples are below. Right, for example, if you happen to be using Ruby on Rails, you have active record here. If you're using Django for a queuing system here, we talked a little bit about Celery here. And by the way, an alternative to active record, or maybe even before we talk about alternatives here, that's basically like a unified interface. It's a database ORM that allows you to use, Postgres, MySQL, or SQLite in a very similar way. Of course, you can always drop down and use like raw query things that don't exist for SQLite, but do for Postgres. But yeah, Active Record is a very good abstraction on top of that. If you're using Python, and if you take a look here at my Flask app, I am using SQL Alchemy. That is a very, very, very good database ORM. Then also, if you're using Django, they have theirs as well, and other frameworks have their own. For example, maybe if you're using Phoenix and Elixir, you could use Ecto instead. Technically not an ORM because there's no objects, but same philosophy there. And yeah, when it comes to caching here, with Rails, they have active support cache built into Rails itself. And in terms of like adapters there, yeah, it could just be in-process memory or the file system, or you could use something like memcached, and nowadays Redis is supported. Same likewise if you use Django, that also supports using Redis as well. Lots of different options for many different frameworks. And developers sometimes find great appeal in using a lightweight backing service in their local environment. Kind of don't agree with that, especially with Docker. Like, why wouldn't I run Redis and Postgres? Like, it's just so easy to just drop them in as a service. Like if I look at my code here and I go to Docker Compose and we look at the Postgres one, let's ignore some of the stuff like setting resource limits here because not important at all. There's the env file, but like, oh, I want to have Postgres running. Cool. Which version do I want? 14.1, like the latest one at the time of making this video. Done. Restart policy, whatever, doesn't matter. Volume, okay, it's important. But long story short, like, that's all I need to have Postgres running on my dev box. If you're running macOS, Windows, Linux, all the same. Likewise at Redis, exact same thing, but I'm just going to run Redis 6.26. Okay, installed. Like I would never ever choose a different alternative, like to use in-memory memory in development, or like SQLite or something. Not because I think SQLite is bad. I think if I were using SQLite, I would use it in dev and prod. I just wouldn't use it one in dev and the other in prod. So I actually wonder what they say about this one here. So they say, a great appeal in using while a more serious and robust backing service will be used in production. For example, using SQLite locally and Postgres in production, or local memory for caching in development and production. Okay, well, I totally disagree with that. And yeah, it sounds like they do too, because 12-factor developer, and that's us, hopefully, right? We're the 12-factor developers here. We resist the urge to use different services between dev and prod because ultimately we're talking about dev prod parity here, right? This stuff should be the same. And basically you would have to fight real hard for it to be the same. Like if you're using some crazy, like, I don't know, some system where you need like 64 gigs of memory to run it or something, like I'm sure there's edge cases, but for normal stuff, yeah, dev prod parity is very good. So even these adapters like Active Record, it supports different ones, but we shouldn't worry about that. Let's just use what we're using in prod. So differences between backing services mean that, there's tiny little incompatibilities that crop up. Like maybe SQLite doesn't support a specific thing that SQL or Postgres does. Or maybe it does support it, but it uses completely different SQL to make that work. Like full text search, probably implemented a little bit differently between the two. I remember back in the day, like SQLite was very different dealing with certain dates. So I don't know what it is nowadays, but there's definitely these incompatibilities. And you don't want to have to make a code change, right, swapping between the two. And what's even worse, not worse, but like, something could totally work with SQLite, and then you commit that and you push it to prod, but prod's running Postgres, and now it's like, wait, that query doesn't work. Like, why is everything failing? Why is the site failing? Why can't customers sign up or whatever? Like, these things really come up. So cause code that worked in past will test in dev and staging, and then they fail in production. Exactly, right? So these types of errors create friction that incentivizes continuous deployment. So the cost of this friction and the subsequent dampening of continuous deployment is extremely high when considered in aggregate over the lifetime of an application, right? Because these things, they're just going to pop up, and before you know it, like over the lifetime of your app, like this may actually happen many, many times, and some of these things could be very severe. So lightweight local services are less compelling than they once were. So modern backing services such as Memcached, Postgres, and RabbitMQ, they're not difficult to install, especially now with Docker. And there's a lot of really good just modern package management systems, right? Like if you're using macOS, you have access to Homebrew. I don't know, I'm sure there's other folks who don't like Homebrew. I think there's like some alternative. I'm not really a Mac user, but there's the other one. And then, if you're using Debian or Ubuntu, you can just apt-get install stuff. You're using a different distro, you know where to go. So alternatively, declarative provisioning tools such as Chef and Puppet combined with a lightweight virtual environment such as Docker and Vagrant. Now, I am really screwed up. If this was written in 2011, there's no way in the world Docker was released then, unless they updated this later. Okay, well, I started using Docker in 2014, so we're gonna have to Google this one here. March 2013. If this is written in 2011, how did that happen? Because if I Google here for 12-factor app release date, which is the only thing I Googled before here, we can see it is released in 2011. So yeah, this had to have been edited at some point in the future to maybe include Docker there, or maybe this was written in 2013 or something and not really 2011. And this reference here is potentially not accurate, or maybe he published that to a blog post in 2011 and it turned into this a little bit later. But in any case, that stuff is not really important here. But they're just saying it is easier nowadays to get these things installed so that you can run them in your local environment. And the cost of installing and using the system is super low compared to the benefit of having dev-prod parity. That's like the real important takeaway, right? So adapters to different backing services are still very useful because they make porting to new backing services relatively painless, right? So, going back to up here, I mean, there's not really that many cases where I've switched over from using Postgres to MySQL or MySQL to Postgres. Usually, whatever application that's being worked on tend to stick with that database unless you run into some serious limitation. But when it comes to something like Active Record, yeah, unless you have very specific queries designed for one specific adapter, then it is fairly interchangeable. Although, there is a cost to trying to move something like, well, how do I transfer like a 500 gig MySQL database to Postgres? Like that's a whole nother problem, but it's not related to the adapter at least. But yeah, adapters, but all deploys of the app developer environment, staging prod, should be using the same type of version of each of the backing services. And that's where Docker really shines as well, because, if I were using RDS on AWS, like I don't know the exact versions that they have, but if I plan to deploy to version 14.1 in prod, then I would just set my dev over here to run this locally and also use 14.1. And then, it's basically going to be as close as I can reasonably ask for. And if I need to use a different version in dev, because we plan to upgrade in prod or something, I can make the upgrade here and go through the motions. And yeah, it just gives me a little bit more parity between dev and prod. Of course, I would test that upgrade in like a staging environment as well, but you get the idea. Let's move on to the next one here, which is dealing with logs. So let's treat them as event streams. So logs provide visibility into the behavior of a running app. So in server-based environments, they're commonly written to a file on disk, maybe a log file, like an access.log or error.log. But that's only an output format. So logs really are a stream of aggregated time-ordered events collected from the output streams of all running processes and backing services. So going back to our code over here, there are technically logs for each one of these things here. The worker, web, Redis, Postgres, etc. And logs in the raw form are typically a text format with one event per line, although backtraces from exceptions may span multiple lines. So logs have no fixed beginning or end, but flow continuously as long as the app is operating. We just looked at this, I actually killed the services here, so there's no more logs coming out, but if these were running and I were accessing the web page and other stuff, activity were happening, it would just be a continuous stream of logs coming out. Now, a 12-factor app never concerns itself with routing or storage of its output stream. It should not attempt to write to or manage log files. Very much agreed. So instead of each running process writing its event stream unbuffered instead, very important, each running process writes its event stream unbuffered to standard out. That's something we're doing here in all of the example apps. So if I run over to this Unicorn config file here, we are logging to dash here, which is Unix convention to basically accept something, or in this case, it means let's write the access log out to standard out. And very similar patterns are happening for the Rails app, a little bit different. I think that's in the application.rb file here. Yeah, we're just saying that we want the logger to log to standard out. We don't want to log to disk. That's because, well, with Docker specifically, yeah, we can just configure Docker to handle that standard out there and then let Docker worry about what should happen with those logs. Like going back down to what they said here, like the app itself, whatever app is being built, it shouldn't concern itself with those logs. Let Docker worry about those logs, or Kubernetes, or, maybe not Kubernetes, but do you know what I mean? Like you can configure these logs to go wherever they need to go and the app doesn't care. That's basically what this comes down to. So during local development, the developer will view the log stream in the foreground of the terminal, right? So we can just view them in Docker Compose, or if you're not using Docker and you're using Foreman or Honcho or whatever, then you can just see your logs there. And staging or production, each process stream will be captured by the execution environment, collated together with other streams from the app, and then routed to one or more final destinations for viewing and long-term archiving. So there's so many different options here. So these archival destinations are not visible or configured by the app, which is actually a great thing because it means every app that you develop, you don't need to worry about like, oh, should I like rotate this log file or do whatever? Like, no, just do all that stuff in one spot and never worry about it again. So instead are completely managed by the execution environment, right? There's all sorts of different log tools that you can use here. And that's really going to depend on what you want. But yeah, lots of options. You can just configure Docker to log using Journal D if you just happen to have one server. And then all of your logs are going to be written out, through standard out from your app to Docker to Journal D, persisted on disk. And then you can use journalctl to look at those logs. Or maybe you want to send your logs over to Datadog, right? Lots of different options that you can do there. But in all of them, the app never cares about anything related to logs. Then we have the event stream for an app can be routed to a file or watched via real-time tail in a terminal. Yep, you can just, Docker compose up and then look at your logs there. Most significantly, the stream can be sent to a log indexing and analysis system such as Splunk or a general purpose data warehousing system such as Hadoop or Hive. These systems allow for great power and flexibility for just looking at your app's behavior over time. So yeah, Datadog is another really good one. That's a modern one, but not that these aren't modern, but yeah, it's just a good solution if you just want to get up and running and just look at something that someone else has created, in this case, Datadog. It's all set up and ready to go. Now, I don't know them personally or sponsor them, but I do use their product and it is a good one. So finding specific events, you could also use something like Prometheus and Grafana in like a Kubernetes setup and self-host your own stuff, and lots of options with logging and metrics and analytics and stuff. But yeah, finding specific events in the past, these are all good things that you can get when you have access to these logs, like large-scale graphing of trends and, such as requests per minute, or how long did that database query take, or, how long did it take for this one controller to respond to a specific request for whatever action that you're hitting. Lots of different opportunities to monitor stuff. And then also active alerting, right? Because you can also say, whoa, this thing happened like X amount of times within a certain time period. Maybe that's a good time to send an email out to who's ever on call or something like that. So yeah, they say here, like, send an alert when the quantity of errors per minute exceeds a certain threshold. So now let's talk a little bit about the last and final 12 factor. My God, an hour and 21 minutes talking straight and my voice needs a break, but we're almost done. And I'm not going to rush it. Let's just do it. So when it comes to admin processes, this is basically running one-off tasks. And a really good one there, just for context, would be like running a database migration with Rails or whatever web framework that you happen to be using. But there's other ones as well, and we're going to get into it. But the process formation is an array of processes that are used to do the app's regular business, such as handling web requests, right? That's the normal web app server that's running. But separately, developers will often want to do one-off admin or maintenance tasks for the app. So very, very common one could just be running a database migration. You want to change your database's schema. Maybe you want to add a new table, add a couple new columns, maybe remove one, add an index, whatever it needs to be. Very, very good idea to use a database migration tool. Lots of popular languages and tech stacks have availability for this. If you're using SQL Alchemy with Flask, you can use the Alembic tool. I actually have a Flask extension called FlaskDB that uses that under the hood. That's what I do for all of my database migrations. That is included here in this example application for Flask. If you go to requirements at text, there is FlaskDB. It uses Alembic under the hood. Works very nicely. Now, additionally to that, you may want to just pop open a console. So if you're using Ruby on Rails, or maybe you're using Elixir and Phoenix or whatever, we have this idea of a REPL. So it's a way for you to basically just connect to your application, and then you just get an interpreter, right? So, I don't want to spin up everything here, but if I just run, because I do have Python installed on my machine, imagine you just open up a Rails console and now you can just start interacting against your application there. So that is, I know that was a Python, but I just don't have Ruby installed, but same exact thing. That's what we're talking about here about a REPL. So you can just open up that console and just run arbitrary code, like whatever you want to execute, you can do that. You can do that in your dev box. Technically, you can do it, on your production server. Implications of doing that, because do you really want to open up a live REPL in your production server and start writing commands? Like, that should be through a system that is a little bit more auditable, because having a developer just do that with no, I guess, I don't want to say repercussions, because maybe they're doing it for good stuff, but yeah, nowadays at Rails 7, what is there, like that 1984 gem DHH may put together? Like, it allows you to get an audit log of folks running arbitrary code through a console. I'll link to that one in the description. But other tech stacks, yeah. they definitely do have the idea of a REPL, but yeah, you can do anything here. So for Python, they have an example there, for Perl as well. And then also there's like separate commands, IRB for Ruby, Rails console for Rails specifically. And then also, besides database migrations or maybe opening a console to run some administrative task here, because that's what we're talking about here, you could also just execute like a one-off script that you just wrote that's maybe it's commit to your app repo somewhere. So in this case, a PHP script that fixes bad records. And, this is a great example here because I am a very, 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 very big fan of separating out my data from my schema changes when it comes to database migrations. So if I were to create a database migration, I would totally make my schema change there, maybe add a column, add an index, remove a column, whatever it happens to be. But if I need to go and like backfill and copy, 80,000 rows of data from one column to another, I am no way going to do that in the database migration. That is going to be a one-off script that I commit to the repo in its own like little subfolder somewhere, and I will run that script. It will do the backfilling of the data separately from the migration, and then that's it. It's a done script. I may decide to delete it from the repo, or maybe move it into like an archived folder or something, just so there's like a record of that. But keeping your data backfilling and changing data separate from schema changes is just much more safe in the long run, because you do not want your database migration to fail. And that, copying data is a totally, totally separate step than, modifying the schema of your database. And yeah, I have a very strong stance on that one. And also just sets you up to be, it's more safe, right? You just have, I'd rather do two, like database migrations are already scary enough in production. Doing two separate things where one can be totally run in isolation, like the schema change, and then the data stuff after, so much more safer, even though it's like slightly technically more work, because instead of just rolling, one database migration file and letting your deploy process run a migration, it's like now you do need to actually, explicitly run that one-off script, but not a big deal. Because it doesn't happen even that frequently. But these one-off admin processes should be run in an identical environment as the regular long-running process of the web app. Right, very, very important there. They run against a release using the same code base, same configs, everything the same. Only difference is you're running your, Rails console command or a database migration command instead of your app server. So the admin code must ship with the application code, right, to avoid synchronization issues. Totally makes sense. Like you would start up a new container to run your migration, or, you could do something like, just some job in Kubernetes through Helm, Argo CD, whatever you happen to be using, or other strategies as well. It's up to you. But the same dependency isolation techniques should be used on all process types. For example, if the Ruby web process uses the command bundle exec thin start, then a database migration should use bundle exec rake db migrate. Right, that makes total sense here because we talked a little bit about dependency isolation before. You should use bundle exec there in both spots. Makes total sense. And, it doesn't really apply that much when it comes to like a Python application because, we just don't have to worry about that. But likewise, a Python program using virtual environment should use the vendored bin Python for running both the Tornado web server and any managed admin process there. So like manage.py is related to Django here. Tornado could be just, swap that name with Unicorn. And in this case, like we're not even dealing with virtual environments when we're using Docker. But if you are, then you definitely want to use the same Python binary here in your virtual environment. So 12-factor strongly favors languages that provide a REPL shell out of the box, which makes it really easy to run one-off scripts. In the local deploy, developers invoke a one-off admin process by a direct shell command inside the app's checkout directory. And in a production deploy, developers can use SSH or other remote command execution mechanisms provided by that deploy executions environment to run such a process. I mean, in my opinion, stuff like this should be super auditable and maybe controlled. So I wouldn't willy-nilly do this stuff, just SSHing into a server to run a command, but maybe that should go through a process instead. But in any case, though, the idea here of just these admin processes should use the same code base, it's just running a different command. And that is going to bring us back to the end. So we made it. This video was like 100 times longer than I thought it would be, but all of these patterns, all 12 of them, super useful. You can choose to apply all of them. You can choose to apply, strictly 100% of every single one, or somewhere in between. It's totally up to you. But I think at the end of the day, if you go through all of these, then your applications will definitely be better in the long run. And that is going to be it for this video. So if you have any questions about any of this, let me know in the comments below. If you liked the video, please give it a thumbs up because it really does help in the end. Thanks a lot for watching, and I will see you in the next video.